Today we will be looking at 5.1, which is dealing with systems of linear equations. So we have three main linear systems here. So our first one can happen when the graph intersects at exactly one point, which gives us an ordered pair as a single solution. So this system is going to be consistent, as well as the equations, they are going to be independent. So if we look at our graph here, we see that in this case we have two lines and they meet at exactly one point, which is 0 and then -2. So additionally, let's go ahead and look at one of our other types of linear systems. So for number 2 here, the graphs are parallel lines, so there is no solution, and the solution set is nothing in this case. So this system is inconsistent, the equations are independent, and finally, if we look at our graph, we see that we have two lines, they have the same slope in this case, and they're going to be parallel. So our third case, what we can have, the graphs are the same line, and there are an infinite number of solutions. So we have two lines, x minus y is equal to -3, and 2x minus 2y is equal to -6. Really, x minus y is equal to -3 is the same line as 2x minus 2y is equal to -6, because all we did was multiply by a factor of 2. And we can therefore conclude that the system is going to be consistent and the equations are going to be dependent. So let's go ahead and look at a couple of methods of solving these linear systems. So our first method is going to be the substitution method, and we can use this to solve a system. So say for example, we are looking at the system of 4x minus 3y equal to 14, and x minus 2y is equal to 1. Let's go ahead and go through some steps to solve this one. So step number 1, what we want to do is solve for a variable in one of the equations. So in this case, step 1, solve for a variable. So solve for a variable in one of the equations. So in one of the equations. And the reason we want to do this is so that we have something to substitute into the other equation. So let's go ahead and look at x minus 2y is equal to 1 and try to solve it for x, because this would be very convenient. So x minus 2y is equal to 1. We can go ahead and solve for x just by adding 2y over to our right hand side. So this will give us an x is equal to a 1 plus a 2y. And now we can go ahead and perform step 2. So step 2, what we want to do is take what we just solved for and substitute it back into our other equation. So step 2, substitute back into other equation. So into and then other equation. Okay, so let's go ahead and do this. So we're going to go ahead and take x is equal to 1 plus 2y and put it back into the other equation, which is 4x minus 3y equal to 14. So that will give us a 4, and we said x is now equal to this 1 plus 2y, so x is going to be equal 1 plus 2y, and then finally minus 3y, and that's going to be equal to a positive 14. So let's go ahead and simplify here. 4 times 1 and the 4 times the 2y will get us a 4 plus an 8y minus 3y, and that's finally going to be equal to a positive 14. And we can go ahead and further simplify. So let's combine our y's here and subtract that 4 over to our right hand side. So subtracting the 4 and combining our y's, we are left with 5y equal to a positive 10, and the last thing that we need to do is go ahead and divide by 5 on both sides, leaving us with a y is equal to 2. So we have our y value. Now we need to go ahead and figure out what our x value is. So we're going to go ahead and take that y value and perform step 3. So step number 3, we can go ahead and use value. So in this case, the y value If you get an x, you can use that as well and try to find your y value. But in our case, we have a y, so we need to find the x. So we're going to go ahead and use our value in one of the original equations. Okay, and doing so, what we should get is an x value because that is what we want to find. So let's go ahead and plug it back into our original. Let's go ahead and pick that x minus 2y equal to 1. So x minus 2y is equal to 1. We have the y value, which is equal to 2. So let's go ahead and make a substitution here. 2 times the 2 is now equal to 1. And let's further simplify. So this will give us an x minus a 4 equal to a positive 1. So add your 4, and x is equal to a positive 5. So what does this give us? Well, this should give us a point. So a point with x value 5 and a y value of a 2. So next we can go ahead and look at another method known as the elimination method. So for this specific system, we have 2x plus 3y is equal to negative 1, and we have 3x minus 2y is equal to a positive 18. So step one here, what we want to do is we want to get one of the variables with opposite signs. So they eliminate. And additionally, you want them to have the same value, just opposite signs. So let's go ahead and try to do the elimination method on this specific system. So let's see what we can do as far as elimination. Well, it might be useful as we see that we have opposite signs here. What would happen if we multiplied the top by a 2 and then the bottom by a 3? Well, we'd get a positive 6 and then a negative 6, which would cause our y values to cancel out. So let's go ahead and try to do that. So I'm going to go ahead, in order to get that 6, we need to multiply the top equation by a 2, and we need to multiply that bottom equation by a 3. So multiplying by each individual element, we should get 4x plus a 6y, so plus 6y is equal to a negative 2, and additionally that bottom equation is going to go ahead and be a 9x, and then finally minus 6y, and that's going to be equal to a positive 54. So if you notice, what's going to happen to our 6x's or 6y's, they're going to go ahead and cancel out. So we can cancel those out, and basically you can go ahead and add what is left over. So this will be our step 2 here. So step 2 says to eliminate and add, in this case, our variables and our constants. So let's go ahead and perform step 2 here. So if we go ahead and add these up, add the 9x and the 4x, and then add the negative 2 and the 54, let's see what that will give us. So that will get us a positive 13x equal to a positive 52. So all we need to do now in order to solve for x is divide both sides by this 13. So x is going to be equal to a positive 4. So now that we found our x value, similar to our previous problem where we got our y value, we need to solve for our other variable, which is going to be y. So let's go ahead and perform step 3. Step 3. And it says to plug in one of the originals to solve for our other variable. Okay, so in this case, we can go ahead and plug it into either one of the original equations, but for this example, let's go ahead and plug it into our original equation of the, in this case, the 2x plus the 3y equal to a -1, and go ahead and try to figure out what our y value is going to be. So we know that x is equal to a +4, so we can go ahead and take the 2 and multiply it by 4 plus a 3y, and that's going to be equal to a -1. Let's go ahead and simplify here. So an 8 plus 3y is equal to a -1, and we can subtract the 8 over to the right hand side, leaving us with a +3y is equal to a -9. Go ahead and divide by a 3. So that should get you a y is equal to a -3, as well as the x is equal to a +4. So what is our point here? Well, we can go ahead and put it in our solution set. So we have an x of 4, and then a y is equal to a -3. Additional information we can note about this is that the system is consistent. So we can go ahead and say consistent. Additionally, we can say that it is independent. Okay, so let's go ahead and move on to solving an inconsistent system. So solving an inconsistent system, we are given the following system of 7x plus 3y is equal to -5, and additionally -14x minus 6y is equal to -10. Now, we could use either the substitution method or we could use the elimination method, but notice how multiplying the top equation by a 2 would give us a +14, so this is a good candidate for the elimination method. So let's go ahead and multiply the top by 2. So that would get us a top equation of a +14x, and then finally, in this case, we would have a +6y, and that's going to be equal to a -10. So now we can go ahead and eliminate. So we can eliminate our x's and our y's, and we are left with, in this case, a 0 is equal to a -20, which doesn't make any sense. So we have no solution, or in this case, nothing. And additionally, we know that we have an inconsistent system, and it is also independent. The next topic we will be looking at is solving a system with infinitely many solutions. So it asks us to solve the system of -9x plus 3y, and that's equal to -24, as well as 3x minus y equal to a +8. So we could go ahead and use substitution or elimination, but this one looks like it would be nice for elimination, as all we have to do is multiply, in this case, the bottom by 3. So bottom by 3 for elimination. So if we multiply the bottom by 3, we actually end up getting a 9. So the 9x's will cancel out with a -9x. So we will be left with the remainder of our y's and our constants. So let's go ahead and multiply that out. So I'm going to go ahead and rewrite the top original, and then the bottom will now be equal to a 9x, and then finally minus 3y, and that is equal to a +24. So the -9x and the +9x, as well as the +3y and the -3y will cancel out, and then finally the -24 and the +24 will cancel out. So that will leave us with a 0 equal to 0, which does make sense, but it also means that we are left with an infinite number of solutions. So what we need to do is actually solve the equation for y. So we can go ahead and say solve equation for y. It doesn't matter which one, you just need to pick one of them and solve for y. So let's go ahead and take a negative 9x and then add a 3y equal to negative 24. This was our top original, and solve it for y. So in this case, we can go ahead and add the 9x over to the right hand side, leaving us with 3y equal to a positive 9x, and then finally minus a 24, and divided by 3. So that leaves us with the line of y equal to 3x minus 8. And then we can go ahead and use this for our final answer. So since we have an infinite number of solutions, the way that we can write this, x, and then when we have x, we have our line of y is equal to 3x minus 8. So we can just write 3x minus 8 because that's equal to a y. Additional information that we can note is that it is dependent as well as consistent. Okay, so we can go ahead and move on to applied problems, writing a system of equations. So step number 1, we want to go ahead and read the problem carefully to determine what equations to set up. Additionally, step 2 says to assign variables to represent unknown values. Step 3 says to write a system of equations. Step 4 says to solve that system. And then finally, we need to go ahead and state our answer and check to make sure it makes sense. All right, let's go ahead and look at this applied problem. So using a linear system to solve an application. So in 2015, the average of the median salaries for the position of environmental compliance specialist in Boston, Massachusetts and Indianapolis, Indiana was $68,947.50. And the median salary in Boston exceeded the median salary in Indianapolis by $7,983. Finally, we want to go ahead and determine the median salary for the position in Boston and Indianapolis. So we need to pick out our information here. The first piece it tells us is that the average of the salaries is going to go ahead and be equal to this dollar amount. And we know that the median salary in Boston exceeds the median salary in Indianapolis by $7,983. So using these pieces of information, let's go ahead and write two equations here. So the first part, we know that the average of Boston plus Indianapolis divided by 2, that's going to be equal to our average, is also equal to $68,947.50. And we can go ahead and create another equation, which is going to be the fact that Boston is equal to, in this case, Indianapolis plus, what was it? 7,983. So in this case, we have two equations. We can go ahead and try to solve for the salary of Boston and the salary of Indianapolis. So let's go ahead and simplify that top one to something that is a little bit easier to work with. So multiply your 2 out from the bottom, and that should give you Boston plus Indianapolis equal to 137,895, as well as the second equation, we still have it. That is going to go ahead and be equal to Indianapolis plus that 7,983. So what we can do now is go ahead and use our substitution method to solve for our desired variable. So in this case, what we will be left with is we can take our Boston and go ahead and substitute that into this equation right here. So that will give us Indianapolis plus 7983 plus Indianapolis is equal to 137,895. And now we can go ahead and do some simplification here. So that leaves us with 2 Indianapolis plus 7983 equal to 137,895. And we can go ahead and subtract this dollar amount over. So let's go ahead and subtract it. And go ahead and subtract that. So this should get us a dollar amount of 129,912. And that's going to be equal to 2 times Indianapolis. And all we need to do to find Indianapolis is go ahead and divide by 2. So Indianapolis will be equal to $64,956. And in order to find Boston, we can go ahead and plug it back into our Boston equation here, which is going to be this secondary one. So Boston is going to be equal to our Indianapolis, which we just found. So 64,956 plus 7983. And that should get us a value of Boston equal to $72,939. So we have Indianapolis, and we now have the salary in Boston. Okay, so let's go ahead and look at linear systems with 3 unknowns. So we can have approximately 4 different types of solutions here. In this case, think of these as pieces of paper. You might have a single solution where all of those pieces of paper merge together into a single point. Also, imagine that these pieces of paper are able to pass through one another. Additionally, they might be stacked in such a way that they have a point of a line in common. And we could also think about them having all points in common if they are all stacked on top of each other and able to pass through one another. Our last example here is that they have no points in common, meaning that those pieces of paper are not touching one another. So keep this in mind when we solve for 3 types of variables. So solving a linear system with 3 unknowns. Step number 1, eliminate a variable from any 2 of the equations. Step number 2, you want to go ahead and eliminate the same variable from a different pair of equations. Step 3, we want to go ahead and eliminate a second variable using the resulting 2 equations and 2 variables to obtain an equation with just 1 variable. And then finally, we find the values of the remaining variables and write them as an ordered triple. So let's go ahead and look at an example here. So it asks us to solve the system, in this case with 3 variables and 3 equations. We want to go ahead and solve this following system. So the first thing we want to go ahead and do is do step number 1. So step 1, we want to go ahead and eliminate one of the variables. So eliminate one of the variables. So in this case, let's go ahead and try to eliminate, as we see, the negative 2z and the positive 2z here. So if we go ahead and try to eliminate those, what are we left with? Well, we are left with the following equations. The 3x plus a 4y, and that's now equal to a positive 14. And the 2x plus a y equal to that negative 9 there. So now that we have found our 2 other equations, we can go ahead and add them together, which will give us a 5x plus a 5y, and that is going to be equal to a positive 5 here. So we can now move on to step 2, and we need to eliminate from our other pairs, which are our bottom 2 there. So step 2, eliminate from, and we're going to go ahead and say the bottom pair. I will also star this equation here so that we can use it for reference later. So eliminating from the bottom here, what do we need to multiply the bottom in order to eliminate one of the variables? Well, we want to go ahead and try to be consistent here, so we can go ahead and eliminate those z's. What do we need to do? Well, we need to multiply by -2 in order to eliminate those z's there. So let's go ahead and multiply that bottom one by a -2. I'm going to go ahead and rewrite the one above it. Okay, and again, we're trying to eliminate those z's. So this will give us, in this case, a -2x, and then the -2 times the -y will give me a +2y. And then finally, this -2 times the +z gets us the -2z, and that's all going to be equal to a +18. So now what happens is our z's eliminate, and additionally it looks like our x's will eliminate. So let's add the result here. That will get us a +3y is equal to a +9. And it looks like we can just go ahead and solve for y here. So divide by 3, and you should get a y is equal to a +3 here. So what can we do with this +3? Well, using our starred equation up here, we can go ahead and figure out what our x value is going to be. So let's go ahead and try to figure out what our x is going to be, and then finally our z value. So let's go ahead and take 5x plus 5y is equal to 5, and substitute in the fact that y is equal to 3. So that gets us a 5x plus a 5 times a 3, and that's going to go ahead and be equal to a +5. So if we go ahead and simplify just a little bit further, we are left with a 5x plus a 15 is equal to a 5. Let's subtract the 15, and we are left with a -10 equal to a +5x. So divide by the 5, and x is equal to a -2. So now we have y is equal to a 3, we have an x is equal to a -2. So now all we need to find is that z value. So we can go ahead, back up to the top, and pick one of these equations that we can plug it into. Let's go ahead and plug it into this first one here to figure out what our z value is going to be. So plugging this into our top equation there, we should get a 3 multiplied by, in this case, our x, which is a -2, finally plus a 4 times our y value, which is a 3, and then minus a 2 times that z, and that's going to be equal to that +14. So doing some simplification, we are left with a -6 plus a 12 minus 2z, and that's equal to a +14. And cleaning this up a little bit more, we are left with z should be equal to a value of a -4. So we now have z is equal to a -4, we have x is equal to -2, and we have y is equal to a +3. So we can go ahead and write our ordered triple here. Usually this will be in the order of x, y, and z. So we can do x, and then our y, and then finally our z value here. And we should be good to go for this specific example. So let's go ahead and look at another example. Instead, we have two equations with 3 variables. So what we need to do is go ahead and try to figure out how we're going to solve this one. So again, let's go ahead and try to eliminate something from these two equations. Notice how, in this case, we could multiply the top equation by -2 in order to eliminate our y's. So let's go ahead and do so. So multiply the top times a -2 in order to eliminate your y's here, and that should give us the resulting equation. So the top one will be a -6x minus a 2y plus a 4z, and that's equal to a +14. The bottom will remain the same as a 5x and then plus a 2y plus AZ, and that's going to be equal to a negative 6. So it looks like our y's will cancel out here, and we can go ahead and write the remaining equation. So negative x plus 5z is equal to a positive 8. Okay, so now we can go ahead and figure out what our x is going to be. So let's go ahead and try to isolate x for this specific equation here. So go ahead and subtract that 5z off, leaving you with negative x is equal to a negative 5z and then plus an 8. And in order to get x positive, we can go ahead and divide by negative 1, or x is equal to, in this case, a positive 5z and then minus an 8. So now that we have our x, what we want to go ahead and try to find is our y. So let's go ahead and try to solve for y. So we want y. So let's go ahead and look at our equations here. Again, we have our 3x plus y minus 2z is equal to a negative 7. And we want to go ahead and try to get this in terms of y. So what will that give us? Well, let's go ahead and write our original out. So 3x plus y minus 2z, and that was equal to a negative 7. Again, this is going to be our top equation there. And again, we want to go ahead and try to get this in terms of y. So subtract the 3x, subtract the 3x, and you're left with y minus 2z is equal to negative 3x minus 7. And then finally add your 2z, and this should give you a y. So y is equal to a negative 3x plus a 2z, and then finally minus a 7. Well, we can make a substitution here because we got the first in terms of x. So we can go ahead and substitute x into here and simplify. So y is now going to be equal to a negative 3. Substitute that x in, so 5z minus 8 plus a 2z is and finally minus a 7. Let's go ahead and simplify this. Y is equal to a negative 15z plus a 24 plus a 2z, and then finally minus a 7. And this should all simplify out to y is equal to a negative 13z, and then finally plus a 17. So plus 17 here. So we have our x, we have our y, and we know that z is just going to be z because we have our others in terms of z. So notice how we have this one in terms of z, and we have this one additionally in terms of z. So we are good to go as far as writing our solution set. So our solution set, since we turned our others into terms of z, would normally be x, y, and z, but in this case we know x is equal to a 5z minus 8. We know y is equal to a negative 13z plus 17. And last, we know, since it's all in terms of z, z is just going to go ahead and be a z. So we are good to go as far as our ordered triple here. The last topic that we have is looking at applications using systems of equations. So let's go ahead and look at an application here. We have 3 customers that went to the store. The first customer spent $11.77 on 2 milk cartons, 1 bag of flour, and 1 bag of chips. The second customer spent $16.72 on 1 milk carton, 2 bags of flour, and 3 bags of chips. And finally, our third customer spent $21.02 on 3 milk cartons, 1 bag of flour, and 3 bags of chips. So what we essentially want to do is figure out how much did each item cost. So we can go ahead and set up the 3 equations here. Let's go ahead and do so. So our 3 equations, from our first customer, we know we're going to go ahead and have 2 milk plus 1 flour plus 1 bag of chips is equal to 11.77. Our second customer, we know that we're going to go ahead and have 1M plus 2 bags of flour, and then finally plus 3 bags of chips, and his total was equal to 1672. And last, we have our third customer. We have 3 milk plus 1 flour plus 3 bags of chips, and that was equal to 21.02. So we need to go ahead and use our methods to figure out what each of these individual items are going to cost. So, alright, so let's go ahead and look at this and try to eliminate the chips from the top 2 equations. So again, it doesn't matter which variables you decide to eliminate, but in this example, we'll go ahead and try to eliminate the chips here. So in this case, what do we need to multiply in order to eliminate the chips? Well, we'd multiply the top by -3. So in this case, let's go ahead and multiply the top by -3 here. So that will get us the resulting equation for the top. We will end up with a -6m minus 3f minus 3c, and that's going to be equal to -35.31. And our original equation here is going to be 1m plus 2f, and then finally plus 3c, because we wanted to eliminate chips here, and that was equal to 1672. So our chips are going to go ahead and eliminate, and we can go ahead and add our variables here. So let's go ahead and add. That should give us a -5m minus f equal to -18.59. So now what we want to go ahead and do is eliminate that same variable from our bottom 2 here. So from our bottom 2 equations here, we want to go ahead and again eliminate those chips there. So what do we need to do? Well, we need to multiply, in this case, that middle equation by -1. So let's go ahead and multiply the middle equation. So the middle equation here by a -1, and that should eliminate our chips. So I'm going to go ahead and star this equation for later. And let's go ahead and move down. So we want to go ahead and eliminate the chips from the bottom 2. So this will get us a -m. So -m and then minus 2f minus 3c, and that's going to be equal to a -16.72. And our bottom equation there is going to remain the same. So 3m plus 1f plus 3c, and that's going to be equal to a 21.02. So all we need to do now is go ahead and eliminate our variables c here. So c is out, and we can go ahead and add here. So let's add and see what we are left with. We are left with a 2m minus f equal to a 4.30. So we can go ahead and look at these 2 remaining equations and try to figure out what one of the item prices is going to be. So we have, in this case, the 2m minus f is equal to 4.30, and we have the -5m minus f equal to a -18.59. So let's go ahead and try to figure out what we need to do. We can go ahead and multiply that bottom by -1 in order to cancel out our f's here. So what will that give us? Well, we'll have the 2m minus f equal to a 4.30, but our bottom equation is now going to become a positive 5m plus a positive f, and that's going to be equal to a positive 18.59. So we can go ahead and eliminate our flour here, and we are left with 7m equal to 22.89. So 22.89, And in order to find the price of milk, we can go ahead and divide by 7. So divide by 7. And your milk price is going to be equal to 3.27. So we found milk, and we can go ahead and try to figure out what our flour cost is going to be from one of these two equations here. So let's go ahead and pick this bottom equation. So this bottom equation, and plug it in for our F here. So that will get us, I'll write our original, negative 5m minus F is equal to a negative 18.59. So let's go ahead and substitute our m in there. So negative 5 times 3.27 and then minus F, and this is going to be equal to negative 18.59. And we need to do some simplification here. What this essentially should get us is a value of a negative 16.35 minus F is equal to a negative 18.59. And all we need to do now in order to figure out what our value is going to be is go ahead and add that 16.35 over to our right hand side to figure out what our flour is. So our flour is going to be equal, we have a negative flour equal to a negative 2.24, and we can divide by negative 1 to get our flour item cost as $2.24. So our last one that we need to figure out is the price of the bag of chips. So if we go back up to our top, we can go ahead and figure out which one of these we want to plug it into. So let's go ahead and plug it into that top one, as we see that C is already isolated as 1C. So plug it into the top one here. So plugging in, we should have a 2 times our milk price, which was $3.27. And we're going to go ahead and add the $2.24 for our flour. And then finally add our cost of our chips, and that was equal to $11.77. So this should get us a final price of our bag of chips equal to $2.99. So in this case, we have our flour equal to $2.24, our chips equal to $2.99, and our milk was equal to $3.27.